So volume to volume stoichiometry, how do we do it? Well, one thing with volume to volume is it can only be used when temperature and pressure are constant. And another thing with volume to volume is it's very, very similar to your mass to mass. So let's take a look at this table here. Now, as we can see here on the left-hand side is the mass to mass. Now, the mass to mass states that the moles of the unknown is going to be equal to the coefficient of your unknown divided by the coefficient of your known, multiplied by the moles of your known. Now, if we take a look on the right-hand side, your volume to volume, it's going to be the exact same formula. But instead of you now calculating it for your moles, you're going to be calculating it for your volume. Now, another thing to note is for our moles of our known and our volume for our known, we must be using the limiting reagent and not the excess reagent. So now let's have a look at a practice question. The complete combustion reaction for propane is as follows. 250 milliliters of propane is combusted with 1,500 milliliters of oxygen gas at SLC. Determine the final gas composition after the reaction goes to completion. Find the limiting reagent by comparing it 1 to 1. That's the first thing that we would want to do. So how can we do this is we need to compare it through a 1 to 1 mole ratio. So we know that propane starts with 250. So because the coefficient of propane is 1, I'm going to divide the 250 by 1. And that's going to give me 250. Oxygen has a volume of 1,500 and a coefficient of 5. So therefore, if I divide this, I'm going to get 300 milliliters. Now from this here, we can see that your oxygen is greater than your propane. So therefore, your oxygen is going to be the excess reagent and your propane is going to be the limiting reagent. So next up, we're going to now use our stoichiometric formulas to now find out the volume of each. So for the volume of carbon dioxide, we do the coefficient of your unknown, which is the carbon dioxide 3, divide by the coefficient of the known, which is your propane, because propane is limiting reagent. So 3 divided by 1 is just 3, and then you multiply it by your volume of your known, and that's going to be the propane 250. So that's going to give me 750 milliliters. Now if I do the same for water, I'm going to get 1,000 milliliters. Now the last thing we have to do is we have to take into account that there is going to be leftover oxygen gas. This is because oxygen gas is going to be our excess reagent. So first off, we need to find out the amount of oxygen gas used up. So we know that the coefficient of oxygen is going to be 5, and we know that there's 250 milliliters of your propane. So 5 times 250 gives you 1,250. So basically what this is saying is we are going to be using up 1,250 milliliters of oxygen gas in this combustion reaction. So therefore, the leftover oxygen gas is going to be the subtraction of the initial and the final. So therefore, I have 250 milliliters leftover oxygen gas. So last bit, the question asks me to find out the final gas composition. So that means the total gas that's left over after the reaction has gone to completion. So I would have to add up all these values, and if I do that, I'm going to get 2,000 milliliters.